So now that we've got our platform moving basically the way we want in terms of hit detection, let's start making it move left and right. Now, if you're coming from the Flash world, and I'm guessing you are, otherwise you probably would have gotten bored and quit about 3 hours ago, you're probably familiar with the Flash way of moving objects. Basically, it boils down to something like this. Suppose I have a box that I want to gradually slide to the right on my screen. I might have some kind of enter frame, listener that will take the X value of our box and increment it by 2. Maybe you're doing something fancier than this. You're probably using some tweening, and you might be smarter with the movement to make sure that the speed isn't tied to the frame rate like this is. But the underlying principle boils down to taking the X value of our box and setting it to a certain position and doing that in little increments to give the user the illusion that something is moving. Now, it turns out that Box2D has a set transform function that we could basically use to accomplish the same thing. Set transform lets you set the position of an object as well as its angular rotation. And we can try something like this to make our own bodies gradually move across the screen. Let's try it. So I'm going to go back into my Puggle application here. And within my bonus shoot actor, okay, first things first, I'm going to set the density of my bonus shoot from 0 to 1. And if we run this, our application will probably, it works the way we expect. Our shoot quickly falls off screen. So let's fix that by making it move left and right. Now, first things first, I'm going to want to create a few member variables here just to kind of keep track of where my ramp is moving and make sure it doesn't go too far off screen. So I'm going to have a little bounds array that will keep track of the left and right values that our shoot should stay within. And I'll keep track of our desired Y position as well. And I will also keep track of the direction that our shoot will be traveling in. This will be a 1 or -1 value, 1 if it's moving to the right, -1 if it's moving to the left. And I can initialize all of that. I'll just do it here. So our bounds array will equal the left bounds and the right bounds. And our Y position will equal the Y position that we pass in and the parameter. And we'll start our direction with 1. We'll start our shoot moving to the right. And to make our shoot move to the right, instead of using an enter frame event listener, I am going to take advantage of this child-specific updating function that we know gets called on every frame for every actor. So I'm going to go through this code kind of quick, and it's going to be kind of crude, but that's because this isn't final code I want to be using in my application. It's code that's here to illustrate a point. So let's start off by taking a look at our costumes X and say if it's greater than second element in our bounds array, in other words, it's gone too far to the right, we'll set our direction to -1, make sure it starts traveling to the left, and if it's less than or equal to our left bounds, we will make sure our direction is 1, so it starts moving to the right. Next thing I'm going to do, just for clarity's sake, I'm going to create an intermediate variable here called new location. This will be a point, and this will basically be the desired point that I want my actor to end up in on screen. So this will be looking at our costume. And basically we're going to take our costumes X, and we'll increment that by, let's say, direction times 2. And then we'll make sure our Y position is this member variable that we've been tracking all along. And then what we want to do is make sure our body is actually at this location. And that's really going to be taking advantage of this set transform function. And remember, we're passing in 2 variables, the position that we want it to end up in meters, and the angle that we want the body to be in. So for the position, pretty straightforward. I'm going to create a new b2 vec2, and I'm going to take this new location, and I'm going to divide it by our phys-eval's ratio value because we are converting from pixels to meters. And then our angle will be set to 0. And, I think in theory that should do it. Let's hit F6 and run it and see what actually happens. Well, okay, this is kind of interesting here. Let's run this one more time, and I'll stretch out the window so you can see what's happening here. It looks like our platform is kind of moving the way we want it to, in that it's moving to the right and then bouncing off and moving to the left. But obviously it is gradually sinking, and that seems kind of strange. I mean, if you take a look at this set transform function, all we're doing is setting the y value of this thing basically to this y position, and this is a variable that we haven't really changed anywhere in our function. So how come our platform looks like it's sinking? Well, this is kind of a mystery, or at least it was to me, and discovering the answer for me involved taking a look at the velocity of this thing. So let's print out a little trace statement here. We're going to take a look at the y velocity of this bonus chute. We're going to take a look with body, and it comes with this great little function called getLinearVelocity, where we can find out the linear velocity of the object. And just to get it in pixels, which is a value I can more easily understand, I'm going to multiply by our ratio constant. Now we're going to run this again. Now as we run this, if you take a look at the output here, we can see the y velocity is gradually increasing. All right, we are already up to about 2,000 pixels a second. If we let this keep going, it'll go to 3,000 pixels a second, 4,000 pixels a second, and so on, up until it hits 6,000, and then it kind of seems to stop. So what's happening here? What's happening is this. We may be setting the location of our bonus chute in such a way that to us it might seem like it's slowly moving to the right across the screen, but it is still an object in our world, and it is being affected by all of the forces that would normally be impacting it, especially including gravity. And so what you're seeing there is, even though we keep essentially teleporting our chute to try and be at a constant y position, it is still accelerating according to all the normal rules of gravity. And so we're basically taking this thing that is falling at a very, very, very fast speed and just trying to set its position back up to where it was before. And I think what ends up happening is we have something like this. We set our box at 500 pixels, but during our Box2D step function, it basically says, oh, okay, this thing that's at 500 pixels is moving at 300 pixels a second in the y value, so I'm going to make it fall a little bit. The next frame, we reset the box to 500 pixels. Again, the Box2D world makes it fall, and so on and so forth. And so that's why you get the illusion that this chute is gradually sinking over time. So one possible solution might be, is there a way we can maybe call this child-specific updating function at a different place so that maybe we set the position of this object after Box2D has tried to make it move according to the rules of gravity or something like that? And the answer is no. It's not a matter of making sure that we pull off this strategy exactly right. It's that our strategy is fundamentally flawed. You have to think of the Box2D world as a real world, a world in which objects are affected by forces. And it's just unnatural to have an object that is, say, constantly being teleported around on screen. In fact, I'll just show you kind of how weird this thing gets. Let's go to our Puggle application. And you know what? I'm going to turn off our pegs for a sec. And I'm just going to go down to our bonus chute. And I'm going to set the bounds a little wider. And I'm going to move this thing up a little higher so that we can try interacting with this chute in our game. All right, it looks like it's gradually sinking. But, okay, that's kind of weird. All right, this thing, clearly something is going on with our chute and is behaving in ways we don't expect. All right, it looks like we've sort of got a ball that's passing through it at times it shouldn't. It's moving back and forth in different speeds. Even though we have set the rotation to 0, it seems to somehow want to be rotating. Clearly all sorts of bad stuff is happening. And this is because we basically have an object that not only is quickly teleporting across the screen, but also happens to be falling at a very rapid pace. And so it looks like maybe our approach of trying to make this thing move through rapid teleportation is probably a bad idea. Now the way we ought to be doing it Actually, the real way we would be doing this might be with a B2 prismatic joint with a motor. However, we're not covering any of this stuff until the next section. Joints are a whole other matter that I don't really want to get into now, so ignore this for now. Instead, let's act as if this were a real object. So no teleporting allowed. If we had, say, a real life object that we wanted to gradually kind of float left and right across the screen, you might have something like, say, a little spaceship with little thrusters that kind of let it slowly move left and right across the screen. And so that's the approach we're actually going to use. Instead of using set transform to set the position, we're going to set the velocity of these objects so that according to the Box2D world, it's actually moving instead of gradually being teleported across the screen. While they both might look the same to you, to the underlying Box2D world, they are very, very different. And so we will tackle this whole approach next.